Thank you so much for joining in. Such a pleasure to host you both at India Science Festival. Let me quickly give an overview and a quick introduction about Professor Dashun Wang. He is a professor of management and organizations at the Kellogg School of Management and, by courtesy, the McCormick School of Engineering at Northwestern University. At Kellogg, he's the founding director of the Center for Science of Science and Innovation, which is the CSSI. At CSSI, Professor Wang leads a group of highly interdisciplinary researchers who are extremely passionate about data. And he has recently come up with his book called The Science of Science, which we are going to be discussing in detail today. So, Professor, thank you so much for joining us. It's a pleasure to host you at ISF. And you're going to be in conversation with Abhigyan Ray. Abhigyan Ray is a very, very interesting fellow and has been a science communicator for many, many years while only being in his undergraduate. He is very, very passionate about research and is interested in the interface of computing, biology, chemistry, and mathematics, and is going to be interviewing Professor Wang about the latest book and has gone through the entire book, read it in detail, and is ready with all the questions. So over to you. Thank you so much.
Oh, great. Thank you so much for having me. Hey, Abhigyan.
It's really fantastic to have you, Professor Wang, and thank you for joining us on a Sunday morning for you. And
thank you for having me, and good evening to everybody who's watching from India. So.
Absolutely. And to be very honest, reading your book has been a really pleasurable experience. And I hope in the next 1 hour, we can glean some insights from you further than what you have delved into the book and all. But before everything, I need to ask you, before you embarked on a quest to decode the science of science, how did your own journey in science come about?
My own journey. My own journey is very atypical. Currently I'm a professor at the Kellogg School of Management and the McCormick School of Engineering at Northwestern. But I started my career in neither of these disciplines. I started my career as a physicist. I was brought up as a physicist. I did my undergraduate in physics. I did my PhD in physics. Following all the typical trajectory where I did my undergraduate in China, and then I wanted to do my PhD in the US, and I was determined to be a physicist until when I was doing my PhD, that's like around the time before Mark Zuckerberg was called Mark Zuckerberg, but it was around the time when all this data about human behavior and social sciences become available. So that's where I started to think about, okay, why don't I apply what I learned in physics to understand social systems that involve humans? So that's where, started this journey. And then I went to, after PhD, I actually went to IBM Research, the TJ Watson Research Center, to help them think about a big data initiative. And so that gets me a little bit further from physics to computer science, and then I now teach in the business school and engineering school. So it has been a exhilarating journey for sure. So, yeah.
Absolutely, Professor Wang. That was a really good overview. And the area of physics that you have been exploring, and one can argue you have never stopped exploring that, complexity systems, is quite an interesting area. And the most recent Nobel Prize in Physics can be ascribed in an overarching manner to the study of complex systems. That's what the citation read. And we had some giants like Giorgio Parisi being up there on the stage. So one can say the physicist in you has never left you, even though you have switched tracks to computer science and now to management school, but you are still a physicist at heart, isn't it?
Thank you. I now call myself a recovering physicist when I go to places. So thank you very much. And yes, it is absolutely amazing year for physicists, especially physicists who are interested in the area I'm interested in, that complex systems finally got recognized very deservingly by the Nobel Prize. And, everybody is very excited about this. And I do think, if we think about the latest insights in the science of science, we have evidence to show a major prizes have this potential to change the trajectory of a field. So, one can only hope that will happen for complex system as well going forward. So.
Absolutely. As you remarked, it was a much belated recognition, to be honest, especially for Giorgio Parisi, who has made some really fundamental contributions in the whole study of complex systems across diverse fields and all. And coming to your book, you talked about prizes, and therefore to jump right in, you talk about how increasingly most of science is being done by large number of teams across fields, whether it be biology or computer science, AI, or gene editing and all. It's teams that are big teams that are driving these collaborations, that are giving us further insights and all. So in terms of that, do you think it's long overdue to sort of change the way the major prize systems work, where it's typically the individual whose contribution is honored, and typically in cases like the Nobel Prize, there are these arcane rules like restricting it to no more than 3 people, as well as sort of like not awarding it to teams. The Nobel Prize in Sciences was never awarded to institutions and teams. So do you see some sort of reckoning is required for these big prizes to better recognize the way science is done in a modern day world and better send out a message to the public at large?
That is a great question, and I believe that's been an active debate overall throughout the scientific community. The overarching question is whether the recognition in science should keep pace of how science is changing. One of the most fundamental changes that happened over the past century has been this precipitous growth of large teams, people working in larger and larger teams. So in some sense, 100 years ago, when, Nobel Prize started, it wasn't issue, it was well designed, if you have only 3 people. And that's roughly the prototypical type of teams back then. And today, when LIGO won the Nobel Prize 2 years after the discovery, it had the paper published in PRL had more than 1,000 authors on it, right? Yet we only award to 3 people and only 3 people. I wanted to first fully caveat this by saying, if you ask everybody who that 3 people should be, and people all agree that should be the 3 people. So we are giving, in this case, the right people who should get recognized. But the larger question remains is that, the LIGO experiment basically built this 2 arms of 4-kilometer long tunnels that housed in the ultra high vacuum that detects a variation that's a trillionth of an inch, right? So this is definitely not a 3 people can dig that hole. There's just no way that could happen. So it's very clear this is much bigger contribution across many years. I do believe so. There are 2 questions basically. One is, should we change the existing prizes that has its own tradition, and the prestige comes from with that tradition. And the second is, what about new prizes? I do believe the new prizes are moving into a direction that try to keep pace with how science is changing. For example, I think the Breakthrough Prize, for example, has been gaining a lot of recognition recently. It has been sort of started to think about how do we recognize teams instead of just individual contributors. And so I think the conversation has begun, and then just like about everything, change will come, but it will take time.
A really great answer out there, Professor Wang. And as you talked about, change is already happening, and it's really essential for these changes to come in, for these prizes, newer prizes like the Breakthrough, to be more recognized in the public eye, because at the end of the day, when the questions related to science funding come about, it's what the public thinks at large largely determines it. And to be honest, Professor Wang, what do you think about the current state of funding for science and academia overall? There are governmental institutions as well as private players. But again, you talk about the discrepancies associated with awards is also seen with grants and the way funding is doled out and all. So how can we build in a more equitable system that also acknowledges the trials and tribulations that underrepresented groups in academia have faced for far too long?
Yeah, absolutely. That is again another very important area right now for us to think about is how do we sort of optimize or just improve the efficiency of funding and make it more equitable and make it more impactful as well. To really give it to the people who need, and this is especially important when we think about funding risky innovations, which has high rate of failure, but if it succeeds, has a high return, right? So over and over, research shows that. But the risky type of ideas is very difficult to capture because ideas are uncertain. In the beginning, it's very difficult for the peer reviewers and panels to recognize that really has the outsized impact. Whereas, probably something that's more well developed will have a clear path towards showing an impact. So I think these are all the things that people discuss. And then there's also a very productive line of inquiry in thinking about whether the distribution of grants is, whether there's gender biases, whether there's biases in race, in other dimensions. And I think these are all important issues that we need to really understand. I think we're at a stage of finding new empirical evidence that systematically informs these debates. I think that's very important right now, is to uncover a set of very robust and systematic facts about the inequalities in funding, about how funding is impactful. And my own work, and including the ones that talked in the book, for example, I talk about a failure, you can also trace people who didn't get a funding versus people who got a funding and see how their career unfolds. And if you study them, you actually got very counterintuitive evidence. And then this sets of evidence, then start to inform decision makers to think about, okay, then really with this evidence, how should we think about funding? The challenge right now in the field is that when it comes to policy changes, what you want to require is a causal evidence that ideally you want to come from a randomized control experiment. Now that immediately gets the problem with funding, because, giving funding randomly around the margin, it seems like a very clear path to understand what's the right way to fund science. But it obviously raises a range of ethical and other concerns that prevents us from really doing this very systematically. A number of groups right now, especially those in Europe, has been trying to push in this dimension, but the progress overall, understandably, is it's difficult to make a very rapid progress in this domain. So.
Absolutely. You have brilliantly laid out the challenges associated with building a more equitable system. And I'm reminded of a terrific excerpt in your book where you talk about the collaboration penalty for women. We have been talking about from the very beginning, we talked about how science is being done in larger teams, and some awards are moving towards recognizing the contributions of teams rather than certain individuals and all. But in your book, you mention how, especially in economics, women who were found to collaborate with men, their chances of obtaining tenure or obtaining grants and awards did not really increase. Rather, there was a penalty associated with it, and it was seen only the men benefited from these things. So that was another great point that you mentioned. So do you think finding more empirical evidence to sort of change the system is what's required? Is there any radical new approaches that are required to sort of bring in more equity in terms of the way people get recognized and all?
Yeah, so that's so the economics example, was very unique and interesting example. This is one of those examples is once you discover the answer, you're like, that makes sense, because in economics, the authors are all perceived as equal contribution, almost all the cases. So they're just listing, for a lot of the papers, they list their name alphabetically, right? So it's not like the sciences where you have the first author and last author that carries the lion's share of the responsibility. And but for economics, it sort of is when listing authors alphabetically, it makes the signal of who contributes more, and that allows the space for human biases. So that's why when female faculty collaborate on a paper, you see the chance for them to get a tenure almost doesn't improve. Whereas the male faculty who co-author on a paper, that paper still counts in terms of predicting the success of tenure. And that seems to explain a persistent tenure gap between female and male faculty. And one caveat here is that we don't really have evidence yet whether this will extend to other disciplines, precisely because I mentioned their publication norm. How do we list people on a paper is different from discipline to discipline. So I think it's important for us for the future work to sort of study more and think about if that has other disciplines has a similar issue. But more broadly, the issue of gender inequality, for example, in science, this is a very persistent issue, right? This is what people call leaky pipeline issue. And the leaky pipeline basically means every step along the way started, you step into grad school, and whether or not you graduate, and then you go to postdoc or not, whether or not you'll be able to find a tenure track. After the tenure track, whether or not you can get tenure. Every step along the way, we're missing women more and more through this pipeline, right? So this is a very, very important and critical issue right now for science, one of the most important issues. And, throughout this, there's more, this is a very heavily focused and very rapidly evolving landscape of research. For that reason, I only touched on this issue, but I haven't covered that. I have a chapter laid out to write, but I didn't include in this first edition, just because the evidence will continue to evolve. And then even just give you an example, after a book published, there was this very interesting paper, I think is going to be very important paper, not by me, it was by one of our colleagues from HBS, Harvard Business School, Ram Corning. He was the lead author. The paper was published in Science after my book was published. And I see that paper as a very, it's going to change the trajectory, how do we think about this issue, because he really pinned down something that's very, very critical in terms of thinking about, what's the gender inequality is translating into a social inequality in the following sense. So he looked at, women inventors versus male inventors. And then he looked at what do these people invent? And then what you find is that women inventors are more likely to invent for women. Women inventors are more likely to invent for diseases and health problems that are specific to women, such as menopause and other women-specific diseases. So what that means is that when you miss women inventors, then you're missing the medical innovations that would benefit half of the population. So to me, that's a very big step in the empirical evidence. How do we think about this issue? Is that this is not just a gender inequality in the ivory tower. The gender inequality in the ivory tower then distorts the knowledge that can be produced from the ivory tower, and then changes the composition of innovations in the world that will benefit men versus women differently. So I think this is where, if you take a longer view, we know that science and innovation is a fundamental engine for economic growth and all the sort of new innovations in society. Now, the gender inequality then within science will have a much far-reaching implication for the entire the entire population at large. So it's not just for scientists, this is a critical issue. I think for the whole society, this is a very critical issue.
Absolutely, Professor Wang. That was yet another brilliant elucidation of the problem and the necessity to combat inequality, gender inequality in science, because it has a significant societal impact too, and all. And coming to which, when we talk about science, we also invariably talk about the papers, the high impact papers, the subsequent citations associated with them, or the high impact factor journals and all. And you dedicate a significant amount of time in your book delving into these citation metrics, the so-called Matthew effect that can be subscribed to papers as well as awards, and both dependently on each other too and all. So coming to it, you are a physicist, as you talked about right from the beginning, and even now you are a physicist at heart. And physicists for the last 3 decades, have had access to the archive preprint server, something that was replicated only in the last decade in other fields, especially the life sciences, the medical sciences, and the chemical sciences and all. So what do you think about the rise of preprint servers, and also the necessity for open access to scientific research? Especially, this is a very persistent question, because recently the social media was ablaze with the new article processing charges to make certain papers open access in what one might call high impact factor journals. And it was a ridiculous amount of dollars, some $12,000, something that's 12 times India's per capita income and all. So in light of these things, what do you think about the necessity for open access science, and what place do you see these high impact journals occupying as science moves towards a more open access and equitable framework?
Yeah, no, this is another great question, and then it's also the very frontier of what we want to think about. Let me sort of talk about open science a little bit from an economics perspective. I'm not pretending to be an economist, but I hang out with a lot of economists. So economists will think about a framework as science is a public good. Okay, so the idea is that if you think about ideas or knowledge, it's a very interesting thing in the world. Just comparing with like a water bottle or a cup of coffee. These are very different types of goods, because the ideas or what science produces is what economists will call non-rivalry, and then sometimes not excludable. So the idea is that if I have the idea, then you can use the idea for free. You can use it. I can't prevent you from using it. Whereas if I'm drinking this cup of coffee, you can't use this cup of coffee. I'm going to drink it, right? So given all these characteristics of like ideas and knowledge, the economists will tell you that basically means there is going to be a market failure. The market is going to underinvest in ideas. Okay, so that means that if you really want innovation to thrive, you have to think about this as a public good. So analogy is to think about it as a park. The government built a park, and then people will visit the park for free. Okay, so I think that's kind of the overall idea, that science is a public good. So the idea is that the government largely, by and large, fund science, and then whatever science produced then can be used by the public, by everybody for free. Just like you think about a public park, you can just visit a park for free. So I think that's the core of thinking about, science needs to be open, and this needs to be just for science to flourish itself. We need to view this as a public good. In fact, our recent paper, and the ones very recent, still under review, actually provides systematic evidence to this idea of science as a public good in measuring the public uses of science and whether this corresponds to the public funding of science. And we see a remarkable consistency across a large, almost all the fields across sciences. So this idea is being sort of increasingly supported. And I think this will inform a range of debates in terms of the openness of science. And this is the idea of how do we make sure science will flourish, in recognizing that this will have market failure if we just let market determine which science would thrive. So now the second point I want to make about the preprints is that I think, let's draw the COVID-19 pandemic as an example, okay? So COVID-19 pandemic was very interesting. First, I acknowledge, this has been has brought tremendous amount of hardship to everybody worldwide and their families and people they love. Okay, so I want to acknowledge that, but at the same time, within science, it is a very interesting event because before 2020, you say summer of 2019, there is not a single human in the world studying COVID-19. Okay, because it didn't exist. In 2000, this hit and start 2020. So 2020 it hits, and then it's a global pandemic, and almost the entire science started to shift their aperture towards apparatus towards understanding COVID-19. Okay, so it is a very interesting shift. In fact, if you look at all the publications in 2020, you will see about 5% of the global sciences were about COVID-19. Okay, so that's a very dramatic shift. Now one question here is to realize a lot of this, because it happened so quickly, scientists were relying on preprint servers to communicate the latest findings and disseminate their research. Okay, so that really facilitated the dissemination of latest results and get people to know each other's advances so they can build on each other faster. At the same time, it also raises a very critical question because everybody's learning this as we go, and the whole understanding of COVID-19 evolves very quickly. So that means the knowledge we produce will not all hold up. Okay, so what that creates a very interesting dilemma is that on one hand, scientists want to get results out quickly, but at the same time, by putting these results in the public domain where everybody can access before these results actually pass through the peer review, can actually decrease the credibility of scientific research in access that the public can access. Okay, so this raises more high-profile issues when there are actually, findings that later proved wrong, which is, happens all the time in science. That's what peer review is for. So the findings later proved wrong, but has already been out there in the public and covered by the news media, and that creates a tons of issue when we think about, how the public consumes science. At the same time, this is also an issue, especially in this era of social media with all the discussions of misinformation, fake news, etc. So our latest, so that prompt does actually study this issue and think about, whether this will be we're motivated by this concern. In our paper published earlier, 2021, in Science, where we actually measured all the policy documents about COVID-19 and see what these policy documents cite in terms of the science that they use to inform their policy. And to our surprise and delight that, it turns out when it comes to a policy document, despite the abundance of research published in the preprint servers, we find that when it comes to policy documents, when people actually make decisions and the science they draw, these proportionally come from high impact, respected, peer-reviewed venues. So that sort of, I think, lessens the concern a little bit is that, when it comes to policymakers, they are relying a lot more on the papers actually pass the peer review rather than just relying on the preprint servers. So hopefully that will give us, the ideal case is that this will give us a platform that has both, benefits on the good things on both ends, right? On one hand, it gives us, a rapid access to the latest knowledge. On the other hand, the peer-reviewed journals still act as very important institution in, elevating the credibility of scientific research.
Absolutely, Professor Wong. That was yet another terrific overview of how the rise of preprint servers has truly revolutionized science, especially in light of the COVID-19 pandemic you talked about, and the concerns of sort of unvetted or lack of peer review, sort of unsubstantiated research can be sort of put to laid to rest based on the points you made and all. And coming to it, you have talked a lot about science as a public good and all. And yet we have come quite far from the times when Newton would pass off as a natural philosopher. But today, someone practicing science, it's not really possible to do that as a natural philosopher. And more importantly, to have your contributions taken seriously rather than dismissed that of being just a crackpot sort of espousing conspiratorial theories and all. So how do you think we can sort of make science more equitable, lessen the barriers for people to sort of explore their own scientific curiosity? And in this light, what do you think about the social outreach and the public outreach needed by the scientists to communicate their own research and science to the general public?
Yeah, I think I think COVID-19 is creating a very high stake opportunity for scientists to think about how to communicate with the public. And I think overall, it's a much more, it's a very complex issue if you think about it. On one hand, every scientist agree we should all communicate more with the public. At the same time, we also know not all scientists, while they're really good at doing science, are good at doing the public outreach. And then, this is further complicated by the fact that, science institutions have not evolved further enough to accommodate how do we reward and recognize people with science outreach, and if not, penalize them already, right? So I think this is a very complex issue that the whole ecosystem needs to all evolve together in order to have more and more fruitful science communications from scientists themselves, right? And so that's my sort of immediate thought on that issue. And then going back to your comment about Newton and back then, and I think one view here, just using his own metaphor, his metaphor about standing on the shoulders of giants, right? So what happened from Newton to now is that this giant has grown much taller, okay? And it's growing taller at a remarkable rate. In fact, if you look at the scientific knowledge production in terms of number of papers published or number of books published, no matter how you look at it, over the past century and more, science has always followed an exponential growth pattern, only interrupted by the two world wars. In fact, it's always been very remarkably robust growth trajectory in science. So what that means is that today's scientists would have a much more knowledge in front of us, okay? So this on one hand is a good thing because you have more knowledge. If I just bought Christmas, the Santa brought my kids a bunch of Lego pieces, and you realize you have more Lego pieces, then you can build a lot more things. So you have more knowledge, then you can combine them in more interesting ways. So on one hand, it's a good thing, okay? On the other hand, it is also a bad thing for scientists, in the sense that, the idea of standing on the shoulders of giants, now I'm using the Caesar's theory proposed by my colleague, Ben Jones, is this idea of a burden of knowledge, right? So the idea is, in order to stand on the shoulders of giants, a scientist must first climb a spike, okay? The taller this giant, the longer is the climb, okay? If it takes longer for you to actually stand on the very frontier, and everybody will have roughly the same, we want to innovate early in life, then the time for you to innovate would become sort of more and more delayed. In fact, if you look at all the greatest inventors in the 20th century, or all the Nobel Prize winners in the 20th century, you see over a century, this time for them to make their breakthrough has increased by about 6 years over the century. So people are also innovating later and later, and that has the broad consequent sort of implications for us to think about the entire innovation engine as a whole for the society, right? So I think that's kind of the view that people right now hold, is that, this is what's really substantially different from Newton's era. And that basically brings together two changes that has been empirically validated. One is that because knowledge grows faster than anybody can absorb, in response, people grow more and more specialized. So the idea is that, in order to get to the frontier within a certain time frame, within a reasonable time frame, such as 5 or 6 years to do a PhD, you have to be more and more narrow in order to get there faster. Okay, and if you look at this through the patent data, etc., people have shown, especially Ben Jones, has shown that this is indeed true. People are less and less likely to be jumping further away through their consecutive inventions. So this is the idea of there is no Renaissance man anymore. So everybody is very specialized. And the second trend that this would bring about is something we were discussing, and we can talk more, is that people will pair up more and more often. Okay, so people work more and more in teams. And this is a very clear trend that throughout the sciences we're observing. But what's interesting here is to think about, if the burden of knowledge makes people want to work more and more, that would mean that people are working in teams not because they want to, but because they have to. They're crippled by the amount of knowledge there is. Now they almost have to work together in order to make substantial advance. So this is sort of, I think, the overall view right now in the literature around this issue. Yeah.
Truly, Professor Wang, you made some really prescient points out there and all. And as we talked about science and the role, we talked about Newton and all. And in this, we also need to talk about the unfettered access to explore one's curiosity. When we talk about science, especially in light of COVID-19, many quickly think of the vaccines. And there is this sort of understanding that the vaccines were developed in record time. And it all happened in a manner of a couple of years. Right, as in January 12th or something, the spike protein was uploaded in the open access genomic server, and in a week's time, Pfizer and Moderna had their vaccine design blueprints and all. But what goes unnoticed is the enormous amounts of fundamental science that has been typically funded by public institutions like the NIH for the last 3-4 decades that were crucial in helping us make these mRNA vaccines in record time and all. So especially in this regard, as we talk about revolutionary technologies like gene editing or artificial intelligence and all, how do you think one can make the case for sort of funding more blue sky research and all, something that underlies these revolutionary technologies but isn't really sort of apparent to the public right at the first glance, and something that sort of conflicts the way science is funded and all? Because across the world, right from countries like India to the US, there is a significant push by people calling the shots towards funding more applied science, more of these hotshot technologies. But in this scenario, how does one make the case for the continued need to fund fundamental blue sky research?
Yeah, absolutely. I fundamentally hold this view, and I'll give you a couple of examples to think about this. It is correct that this vaccine development during COVID time is a remarkable achievement. It's unprecedented, I believe. I don't think there's been this rapid development, and this is the first time that mRNA being used for vaccine as a technology, right? So, and it's just spectacularly successful when you think about how the vaccine is working right now. So, but this didn't come from nowhere, right? So this mRNA vaccine didn't come from like, okay, 2020 is the year we're developing mRNA vaccine, and then by the mid-year we got it. That didn't happen. It started back to several decades, when Dr. Carrico, for example, and others were working at Penn, University of Pennsylvania, they started to think about this sort of fundamental sciences. They're thinking about mRNA, right, as a potential therapeutic and other applications. And for the longest time, they didn't quite get it to work, right? And then before COVID, they were also testing mRNA vaccines for other things. They didn't know COVID is coming. And then as they were testing for it, and then COVID comes, that also enabled them to rapidly pivot, okay? So that has several implications I want to discuss, okay? So first is to think about this remarkable lag between the fundamental sciences and the application, okay? So this is a ongoing area of inquiry. One thing I touched very briefly in the book is if you think about one of my favorite paper is a 2018 paper in Science Translational Science. In that paper, the authors did a very manual process in that they look at, in the 20th century, the 25 most transformative drugs in the world. Okay, so these are the 25 life-saving innovations. Okay, saved countless lives. Okay, this includes the familiar example like a statin, like to lower your blood pressure and so on. Now they trace for each of these drugs, they start to interview experts and say, what are the fundamental scientific advances that eventually lead to this drug? For the statin, then is a famous example, leads to 1976 paper by Goldstein and Brown, who later won the Nobel Prize for discovering the LDL, which is the bad cholesterol that people talk about, your doctor tell you about. Now, look at all these most transformative drugs, you look at, okay, between the scientific discovery to the FDA approval of drugs, you see on average, that's about 35 years. 35 years. Now, that is the remarkable lag, okay? So that tells us, for a long time, we will not know, eventually will save us lives, will save us from, millions, if not billions of lives, but for a long time, we will not know its practical application, okay? So, and at the same time, at the time of discovery, you actually may not know, when this will be applicable and how this will be applicable, okay? So that's one idea of this remarkable lag is that at the time of discovery, you won't know, it's very uncertain, you won't know that what this will enable, okay? So just like, the Wright brothers invented be able to fly, initially fly. So the Wright brother achieved something remarkable in that it made an object that's heavier than air being able to fly, okay? And only fly for 100 meters, for example. But that concept 60 years later is what enabled us to land on the moon. So I think, but at the time of discovery, it's very difficult for you to anticipate when this will pay off. But second implication of this is that, unless you actually have the technology ready to go, when you need it, it will take a long time for you to actually invent this, okay? So if we didn't have mRNA vaccine, we would not have the vaccine. We're already inventing mRNA vaccine for some other things. When COVID comes, we will not be able to do it, okay? So this is where what we call, in a recent study, we're studying called a great pivot. We're looking at how people pivot from their research to COVID-19. And that leads us to learn something really interesting. Is this idea around human capital. Is that the ones who were really successful in solving the COVID crisis were the ones already well positioned to solve it beforehand. So this means if you want to position human as a species to anticipate emergent threats and crises, you need to have a sort of being prepared. So the Pasteur says chance favors a prepared mind. But in this case, it's because chance favored a collective mind that needs to be prepared, okay? Because it means the entire science, we need to take an ecosystem view that allies, because we don't know what the new threats will be, what new crisis will emerge. So if we want to truly be prepared, we actually need to place all the bets and facilitate all the areas, even if in some areas we don't know how they will pay off. Because when the crisis happens, it will take a long time. If we're not already prepared, it will take a long time for us to come up with something that actually is useful. Okay. So I think that's kind of the two implications I see as this remarkable lag that we really need to think very carefully about in terms of funding, not just applied science, but also basic science. I think both are important.
Absolutely fantastic points out there, Professor Wang. And you have made some really prescient points that are especially important to take note of as we see the answer lies in sort of fundamental science discoveries that were made long ago that only spurred the applied science innovations, especially in times of crisis and otherwise too. And so with this is a book talk on your fantastic book, The Science of Science. So what really motivated you to write this book, to delve into the science of science? And how did you go about writing the book? You had a co-author, so did you take bits and pieces and you all wrote individual chapters and it all came together in the end? Or did you have some other approach to writing a book with a co-author and all? So how did this all journey to your book come about?
So the book is with Lázaro Barabasi, which is a longtime collaborator and friend of mine. So we together worked on several many different projects. So we have very good working relationship already. So I think that sort of really helps in terms of this very close relationship in sort of writing together. So we have a very cohesive view on what the literature is about and really help us to put our heads together and collaborate on this. And it's always, I always say, it's like always a great experience to work with Lázaro and so on. So it's been a great, I think it's a great cultivation of many years of our relationship to this book. When I get into this, I want to say sort of, when I started this research, a lot of the questions I was asking myself were actually self-serving in a sense, because, I started out, as a graduate student and getting my PhD. So it's a very early career researcher. So I started to have these questions just about my own profession. Say, if I want to succeed in my own profession, I want to know, what are the successful things people have done? What are the patterns underneath the successful careers? When do they do their greatest work? Now, how do they select collaborators? How do they collaborate with each other? What's the recipe of thinking about a great paper? Why a paper gets really great, highly cited? Is this about their very novel or not? These are the set of questions I think every early career researchers would like to know. And I think, that sort of began as as an inquiry. But one thing I want to highlight is, the book is called The Science of Science. But so this is about turning the scientific methods and curiosities on science itself. But this is not a new idea, right? This idea goes back to, at least mid 20th century. There's a huge number of highly influential giants, including, Robert Morton, the sociologist of science, thinking about the idea of Matthew effect. The Solar Price, the physicist turned historian of science, thinking about the idea of power laws, invisible college, etc. Or, Harriet Zuckerman, another, sociologist of science, thinking about Nobel Prize winners. Or Thomas Kuhn, for example, thinking about the paradigm shifts. Or Eugene Garfield, thinking about the science citation index. At least go on and on, right? So the question is, what's so new now? Why does this sort of what is so new today? I think basically there are two things, right? One is this massive amount of data that we now have that these giants didn't have the luxury to have in their time. And this amount of data in science is becoming available in a truly remarkable rate. In the sense that if you look at the literature, you will realize every year there's some new data that become available that you didn't think it was possible just a year ago. It was true this year, it was true last year. The past couple of years is always like that. There's always new data become available, and all this new data, as I mentioned, will enable us to uncover new empirical evidence to inform key issues around science, right? I think the second force that's really making today's this science of science flourishing is a range of high impact tools that are really useful to help us make sense of this data. So this includes complexity science, as we mentioned, includes network science, but also includes artificial intelligence. All these tools that are now being invented that come together that really help us fully exploit the potential of all these data sets. So in the sense that if we had this data 20 years ago, we probably wouldn't know what to do with them because the tools are not there. But today, the cars are driving itself, and all these tools are now becoming available for us to actually use and make sense of all this data. So I think that's where together, when we combine, we're building on this fundamental school of thought on understanding of science over the past, a century, a half a century, but infuse them with this new two elements of data and tools that really enable us to start understanding science in a way perhaps we couldn't, many, many years ago. So that's kind of where I think is really interesting. And this is where, going back to my initial comments on why we're writing the book, is that, when I was thinking about who is the audience of the book, okay? So, I think this is where we actually, truth be told, we wrote two versions of the book. And the first version never saw the light of the day. What you're seeing is the second version where we script everything and rewrite everything. So the idea is that initially we're thinking about, okay, we're writing a book, so we're writing for people who are working in our field. Okay, so that's the initial way of thinking. But if you have read a book, you realize that's not the case for this version, because the idea here is that, the insights, just like when I was young and I started by thinking about these questions, hoping to help my own career, what we realize is that what the science of science community has to offer is not just some scientific findings, but that these findings have fundamental implications for scientists and science decision makers to try to better the outcome of their own scientists as well as their collaborators. So I think that's where we hoping this book will help, is that by giving you a systematic set of facts and the insights inferred from a set of models and understandings of science will help us better understand, the fashion that we all share, which is science. Mm-hmm.
Truly, Professor Wang, having read the book over the past fortnight or so, it has been a really pleasurable experience. And you also direct the Center for Science, Society and Innovation at Northwestern University. So what exactly is the sort of research interest that you all have over there? Is it something sort of mirrors that of the rationale behind your book and all? And how exactly do you promote interdisciplinarity between sets of researchers across different schools of thought?
Yeah, absolutely. I think, at the center, we're really hoping that we create a more interdisciplinary environment for us to think through the issues around science and innovation. And this means, in terms of researchers, we're very different. There's people from hard science backgrounds, such as applied mathematicians, computer scientists, or physicists. There are also people from social science backgrounds, such as management, or political science, etc., or psychology. So all of these people come together. I was hoping that we all bring different perspectives, but at the same time, we also wanted to enable a very collaborative environment. So everybody come together and they bring their different perspectives. So hopefully, by combining these diverse approaches, that will allow us to attack bigger questions faster. So that will be the overarching hope. And at the center, I think we're very simple. There is a very simple way of thinking about this. So the center is called Center for Science of Science and Innovation. The idea, I think, is very simple, is to realize, when I look back to the past 100 years, I think about what has been most important for humanity. And the answer is always been, I think very few things have done more for humanity than science and innovation in terms of improving human conditions. We really achieved a remarkable progress over the past 100 years in terms of improving human conditions. Now, our bet is that, going forward, in the next 100 years, the role of science and innovation as the fundamental engine for economic growth and prosperity will only become more important. So the idea is that now, I think at Northwestern, we feel like now there's an opportunity to think about it in a fundamentally new way of thinking about how do we approach science and innovation. So the idea is then, can we think about the question of how do we foster innovation that will improve the quality of life and the standards of living over the next 100 years? So I think that's an overarching question we're asking ourselves. And the hope is that with all these data sets and the tool sets, combined with the social science thinking, maybe we can provide something that's useful in thinking about this question.
Truly, Professor Wang. And you talked about the ubiquity of science in our daily lives and the high impact it has had over the last century. And it will continue to go on as we talked about revolutionary technologies and all. So lastly, what are your thoughts on the role of public engagement platforms like the India Science Festival? And how has it been your experience attending ISF over the past few days?
Oh, this has been the first time I'm involved in this event. I feel really honored to be involved in this, and I think I'm really impressed with what you guys are doing, and this is a truly fantastic experience. And hopefully I'll be able to engage more, and at the same time, hopefully we'll be able to engage with the especially audience in India in thinking about this issue. And just a quick plug, by the way, you can certainly buy the book from Amazon, but also the book is freely available through my website if you just search. We also wanted to make, this gets into the idea of open science. So we really wanted to make sure everybody had a chance to read the book. That's first and foremost and most important. Now, second, I wanted to sort of mention is, also I believe the Hindu translation version of the book is still up for grab. So if you're interested, please get in touch. We would love to bring this book to benefit more of people in the country. So hopefully that will help. We all think about sort of science, how to further science. Yeah.
Truly, and thanks a lot for engaging us over the past 1 hour in a really fantastic session, delving into the science of science. And to all the listeners out there, I can't really recommend the book more. It has been a really surreal experience reading it and sort of gleaning in very interesting insights over the last fortnight and all. And with that, thank you, Professor Wang, for your time.
Thank you so much. Thanks, everyone.
So much, Professor Wang. This is, here's hoping that we get to host you at the festival once again in an offline setting. And here's hoping that you'll be with us in India, where you'll engage with all of our attendees on a closer level. And thank you for being a part of the festival and for talking about such a relevant topic. Congratulations to you and the co-writer of the book for putting together such a wonderful book. And here's just letting our attendees know that the link to the book is in the chat. So please do go look it up. And it's up for grabs in Amazon. So do feel free to buy it. And thank you so much, Professor Wang. It was an absolute pleasure. Thank you for your time. And Abhigyan,
thank you very much.
So much for carrying the conversation forth and for being so enthusiastic throughout. You've done your homework very well, and the questions that you posed were absolutely lovely. So thank you so much for engaging with us. A big thanks to both of you.
Hey!